let's perform our chi-squared test for equal population probabilities on our exterior colours. To start, we need a summary table of our exterior colours. One of the easiest ways to do that is to create a pivot table of this data. So if we highlight, go to Insert, and Insert Recommended Pivot Table will give this to us. We can get the sum of count by exterior, and there we are. Zoom in a little. We've got our data here, but it turns out that doing calculations on this data is a little bit awkward, so it's better for us if we take this data, copy it, and paste it, but paste the values. Now, this data is raw data that can appear in a formula easily. It turns out that Excel doesn't like to use these data values within formulas. Okay, so now let's work on creating our chi-squared test statistic. Our first step is to create our expected values for each of the car exterior colours under our null hypothesis. Well, our null hypothesis here is equality. So we expect that blue, red, silver, and white will all be equally likely to be chosen. Then we would expect out of the 200 cars that 50 would be chosen in blue, 50 in red, 50 in silver, and 50 in white. To continue calculating our chi-squared test statistic, we need to calculate the contribution to chi-squared in each of the color categories. To do that, we're going to take the squared difference between the number of observed observations in each category and the number of expected observations in each category. So E5 here is the number of observed blue choices, subtract off the number of expected blue choices, square that, and then we divide this by the number of expected blue choices. Alright, let me show that formula. We'll do this for each of the car color categories. Our easiest way to do that is to drag this down. That'll repeat the formula for each of the colors. Show those formulas there. Now let's get the sum of the contributions to chi-squared. That will give us our chi-squared test statistic. Finally, we need to see whether this chi-squared test statistic is extreme enough to reject our null hypothesis. Our easiest way to do that is to find the p-value for this test. The p-value is the chance of observing a chi-squared test statistic this extreme under our null hypothesis. This is going to be a small number close to 0 if we are rejecting our null hypothesis, and if we're accepting our null hypothesis, this will be a large number, though large here means bigger than 0.05. So we're looking for a number smaller than 0.05 if we're going to reject our null hypothesis. Let's see what we get. We're going to use the formula chi-squared dist right. So chi-squared dot dist dot right, because we want the right tail of this test. High chi-squared test statistics are extreme chi-squared test statistics. Low chi-squared test statistics are non-extreme. Okay, we've got 3 is our test statistic, and we have 3 degrees of freedom, 1 fewer than the number of categories. So let's do that. We get a p-value of 0.39. 0.39 is not below our threshold 0.05, so we do not reject our null hypothesis. We conclude that we do not have evidence that the car exterior colours are unequally likely to be chosen.